A T-ball with a mass of 0.1 kilogram travels in the air at 30 meters per second until it is stopped in the glove of a shortstop over a period of 0.2 seconds. What impulse was imparted to the T-ball? Okay, so we have our givens, and we've read the problem, so we're going to go ahead and reread it. A T-ball with a mass of 0.1 kilograms travels in the air at 30 meters per second. This is a speed or velocity because it's meters per second. So we're going to call that V, and that's equal to 30 meters per second until it's stopped. Stopped is another velocity. So this is the initial velocity, and stopped is our final velocity, and that has a value of 0 meters per second. In the glove of a shortstop over a period of 0.2 seconds. This is time. What impulse was imparted to the T-ball? So we've got our unknown, and we're looking for impulse. Impulse can be calculated by multiplying force multiplied by time, or finding the change in the momentum. And in this case, we're going to use change in momentum. I went ahead and wrote that here, but actually we're going to bring this down. Force multiplied by time equals mass times velocity minus mass times initial velocity. Let me go ahead and erase this just so we're not confused. Probably, it doesn't matter. It's both written there. We're looking for the impulse, which is force multiplied by time. And we've decided here that we're going to find the change in the momentum, and that's going to be the way we're going to find the impulse. So that's better. Okay. So now we're going to substitute. So force multiplied by time is equal to the mass, 0.1 kilogram, times the final velocity, which is 0 meters per second, minus the mass, 0.1 kilograms, times the initial velocity, which is 30 meters per second. So the solution is going to be 0.1 times 0, which is 0 kilogram meters per second, minus 0.1 times 30 is 3 kilogram times meters per second. And if you take the difference between those two, it's minus 3 kilogram meters per second. And there's your answer. It says find the units in kilogram meters per second. That's what we have. It says what impulse was imparted. And so it doesn't say what is the magnitude of the impulse. It says what impulse. They want the vector including the direction. This really makes sense because if this is the ball and it's traveling in this direction and this is the initial velocity, when it gets to the glove, when it hits the glove, it has a velocity of 0 meters per second. So to slow something down, you have to push on it in this direction over a period of time to decrease its momentum. And so this force has to be negative. It's got to be a negative. If this is the positive direction from left to right, then from right to left is negative. So this negative sign makes a lot of sense.